All right, take 251 is the first part of two parts of identities. Now this first part is really going to be mostly what identities are and the concept of using the identities. We'll simplify a few expressions using identities. And then part two will be working several of the problems that you see in textbooks. So let's start with part one then and the concept of what identities are. Now what we're going to look at first is this equation. It has an equal sign in it, so we call it an equation. And this is a conditional equation because what is the solution of this? What number can I plug in here for y and get this to be a true statement equal 8? And the answer is y is equal to 4. Are there other numbers that we put in here? And the answer is no. The only number for a correct solution to make this equal 8 is the letter y. It has one solution. This is a conditional equation. Its condition to be true is for a value of 4 for y. Let's look at the second equation that I have in the notes. And this is, again, an equation. Again, it's a conditional equation because what are the values, plural, what are the values of x that will make this true? Well, let's see. If I put a 3 here, that's 9. Minus 6, that's true. So x is equal to 3. If I put a minus 1 in here, I get positive 1. Plus 2 is plus 3. That's true also. So therefore, this is also a conditional equation that is only true when x is positive 3 and x is a minus 1. Conditional equations. But now the third equation I have in the notes, this is called an identity. Still an equation, but it's called an identity because of this. This is true for any number. If I put 5 in there, and there, and there, it's true. If I put 10, it's true. If I put 4.321, it's true. This equation is true for every value of x that exists except a minus 1. Except a minus 1. So listen to this sentence. An identity is an equation that's true for all permissible values. Now what they mean by the word permissible is if you plug a number into it and makes it not possible, division by 0, then you can't use that number. Otherwise, it's true for all other numbers. So an identity is something we're going to say, this thing is true for all angles when we look at trig. All right, now, let's now look at the identities that you need to memorize. In your textbook, you'll have a list of them, but you have the identities that you need to memorize. And the first one I have in the notes is the cosecant of any angle is equal to 1 over the sine of any angle, any permissible angle. You see, the cosecant of 180 degrees does not exist. So we can't use 180 degrees. Sine of 180 is 0. Here we'd have 1 divided by 0. So there's certain angles that we cannot use, but identity says this thing is true for all angles except 0 degrees and 180. That's an identity. Well, that's one of them you must memorize. But wait a minute. I'm saying to you, not just memorize that, but memorize that in all its forms. For instance, you need to know that the sine of theta is 1 over the cosecant of theta. Okay? All I'm doing is switching places here. All I'm doing is saying memorize this one. Also, you need to know that the sine of theta times the cosecant of theta is equal to 1. They're reciprocals of each other. Reciprocal means 5 times 1 over 5 is equal to 1. It means 3 halves times 2/3 is equal to 1. It means this times its reciprocal is equal to 1. Now, using these identities in other math classes and in trig, it's a matter of sometimes you'll see this And you need to learn to just replace this. Anytime you see the sine of an angle times the cosecant of the same angle, same angle, same angle. All of these are based on being the same angle. So when you see sine times cosecant, then you get to replace that. Just say, hey, all that's equal to 1, so I'll just replace it with a 1. Listen to this. Whenever you see the sine of theta, I'm going to replace it with 1 over cosecant. Now that's the key word to the concept of proving identities. It's replacement, being able to have 1 over cosecant and say, well, that's equal to sine. Or having sine and say, well, that's equal to 1 over cosecant. Or having sine times cosecant, saying that's equal to 1. That's the concept. So you need to know the sine of theta is 1 over the cosecant. The cosine of theta is 1 over the secant. Or what? The secant times the cosine's 1. Or the secant's 1 over cosine. All right? Another one that you need to know is tangent. These are all in your book, of course. Tangent's 1 over cotangent. Or what? Cotangent times tangent's 1. Now you must memorize those three in all the different forms. Sine is 1 over cosecant. Cosine's 1 over secant. Tangent's 1 over cotangent. All right, let's look at the other three now that you must memorize. If you look in your textbook, there'll be number 7, 8, and 9. Number 7 is sine squared plus cosine squared is equal to 1. Now what this says is, listen again closely, the sine squared of an angle plus the cosine squared of the same angle is equal to 1. Now just briefly why all these are true is because of this. Sine is y over r, so if I square that, and cosine is x over r, and if I square that, well, that squared is y squared over r squared. This is x squared over r squared. Common denominator says y squared plus x squared over r squared. And what is x squared plus y squared? It's r squared. So all of these identities are based on x, y's, and r's. All right? Okay. Now, let's go back and say this. Coming back to this, saying sine squared plus cosine squared is equal to 1, you must recognize it as the sine squared is equal to 1 minus the cosine squared. There'll be many times when what you'll do is replace 1 minus cosine squared with sine squared. Or you'll replace sine squared with 1 minus cosine squared. The concept is replacement. Or you could have cosine squared is equal to 1 minus sine squared. Or you'll probably have to see it this way. What is cosine squared minus 1 equal to? Well, what that's equal to is a minus sine squared. Because what you do here is if you factor out a minus, okay, well let's take it this way. Let's take this and multiply both sides by minus. I multiply both sides by minus, that changes that to 1 minus cosine squared. So what I'm saying then is cosine squared minus 1 is a minus this. Okay. So you must be able to see the identities in several different ways, all right? Okay, let's look at the next one. 1 plus tangent squared is equal to secant squared. 1 plus tangent squared is equal to secant squared. Okay? Well, that means then I need to see 1 is equal to secant squared minus tangent squared. Or tangent squared minus secant squared is equal to a minus 1. Now, the way I get these is by moving them across. If I move this across, it becomes the minus. and then I move the 1 across over here, it becomes a minus 1. Back up here, if I move this across, it becomes minus tangent squared, and it leaves the 1 over there. But again, over and over, I'll say this in this chapter, and that is, you must have these memorized, and then you must see them in their other forms. I'm not saying you memorize the other forms. You memorize these basic ones. And the other one, the left one that I'm not going to show in the notes is 1 plus cotangent squared is equal to cosecant squared. Know those by memory and then see the algebraic movement. All right, now let's use these identities, this replacement concept, to simplify problems. So we have the cotangent to the 4th power minus the cosecant to the 4th power over cotangent squared plus cosecant squared. Now, in order to do this, you must know your algebra. You better know how to get factor. You better know how to get common denominators and do all kinds of different algebraic processes to be able to use the trig identity. A lot of times the trig identity is just one of 3 or 4 steps in a problem. All right, here we go. The top one then will factor. It will factor into cotangent squared minus cosecant squared times cotangent squared plus cosecant squared. In other words, think of these. Now listen to me. Think of these as x and y's. This would be like having x to the 4th minus y to the 4th over x squared plus y squared. So the top one factors x squared minus y squared, x squared minus y squared, x squared plus y squared. All right, the bottom one we'll leave alone. Cannot factor anyway because it's a plus. And look what happens. These two drop out. And so we're left then with cotangent squared minus cosecant squared. And that's an answer. However, we want to change it to another form. Let's see. That can be, hey, isn't that just a 1 minus? Other words, think of the identity 1 plus cotangent squared equals cosecant squared. So if I move this across and make it a minus, then I need to move the 1 across and make it a minus. So some students can just look at that and say, hey, it's a minus 1. This is not the point. This is not the point to be able to see it quickest. The thing about identities that all of you need to know is that for some people these become very easy. Some people just see them real quick and other people don't. It is not a sign of intelligence. It is not a sign of whether you're going to be good in trig or not. It's just something that I've noticed over the years that some people, it just happens easy for them and other people struggle with it. What I want you to know is this. You can still get there whether you're struggling or not, because what you do is then go look at your notes and memorization and say, okay, well now this one I can replace. Okay, just replace it with what it's equal to, 1 plus cotangent squared. So if you'll memorize the basic ones and just know replacement every time, you'll get there. Just know replacement. For that, I can replace that. So that gives me cotangent squared minus 1 minus cotangent squared. And look what happens. Those drop out and we still get a minus 1. So I'm saying to you, you do have to know algebra, no matter what. But you don't have to know all of these identities in every way as long as you know the basic 8. And you can come back and just replace. Replace with one you have memorized. Cosecant squared is 1 plus cotangent squared. And then do algebra. It'll work out. All right, let's look at the next example. All right, the next example again requires algebra. Don't you dare go through this and, hey, I got a sine here and a sine cubed, and I'll mark out. Okay, because if you did, this would mark out and give you sine squared. This would mark out and give you cosine squared. That's equal to 1, so all this would be equal to 1. And that's not true. Right? Because some of you probably noticed on that example I worked before that if you marked out like that, it would worked out. Just lucky. Right? So we must do algebra. Well, what the algebra here is factoring x cubed plus y cubed. Okay, for this numerator. So think of that as x cubed plus y cubed. Well, that factors as the first one plus the second one. And then it's the first one squared. To factor this, it's x plus y. And then it's x squared plus, minus opposite sign, whatever this is, opposite sign, xy plus y squared. So this then would be sine squared x minus sine of x cosine of x plus cosine squared of x. Alright, remembering now that's all over. Sine of x plus cosine of x. That divides out. And look what we have right here. Alright, now again, listen to this. What is cosine squared plus sine squared? That's 1. And so that's the answer. Now, again, what I said a while ago. If you don't see this, then just replace. What is sine squared equal to? Well, sine squared is equal to 1 minus cosine squared. And look what happens. This minus and this minus drop out, and we still get our 1. Okay, now let's look at the next example. Okay, now then let's learn how to do this 2 ways. One is by, here I have a fraction. What do you do if you have 1/2 plus 2/3? Well, you get a common denominator. So the common denominator is this and this. So I'm going to multiply the top and bottom by a cotangent. So I'm going to have cotangent squared of A over cotangent of A times sine of A minus cosecant of A. Plus, I'm going to multiply the top and bottom here by the other denominator, which is sine of A minus cosecant of A. So I'll have cotangent of A times sine of A minus cosine of A, cosecant, excuse me. Sine of A times cosecant of A. All right. So what I did is I multiply the top and bottom so I have a common denominator. So now let's write that over the common denominator. All right. So I have cotangent of A times sine of A minus cosecant of A. On the top I have cotangent squared of A plus, and then we'll multiply this out. Look what happens. Cosecant times sine is 1. And cosecant times cosecant is cosecant squared. Now here again is where you can still get the job done. I said cosecant of A times the sine of A is 1. If you don't see that, then go replace. What is the sine of A equal to? Well, the sine of A is equal to 1 over the cosecant of A. Now, when you multiply that by that, it drops out. So you can still get there by replacing, if you know by memory, the first 8 memorizations that you're supposed to know. All right, well, let's finish the problem off. Let's see. Wait a minute. What is cotangent squared plus 1 right here? Cotangent squared plus 1 happens to be cosecant squared. So right here, I'm replacing it with that. And so that answer then is 0 over something. And so the answer is 0. Let's just see what happens on the bottom. It doesn't make any difference. If the top is 0, the final answer is 0. Okay, it's provided the denominator is not 0, of course. If we get 0 over 0, then we have another situation we do not want to deal with. Okay, let's see what happens on the bottom, though. Listen to this statement. When all fails, when I don't see anything else, change everything to sine and cosine. All right, so I'll change cotangent to cosine of A over sine of A. And I'll change sec to 1 over sine of A. Now the denominator then would be what? This times that just gives me cosine. And this times this gives me cosine over sine squared. But it's still 0 over that. That's not 0. So it's 0 over that. So the final answer is 0 in this problem. Now, listen again before we go to the next part of this tape. What I'm saying at these last 3 problems are for is just to say, working identities, you have to know your algebra, common denominators, you have to know replacement. And so you need to memorize those identities. Okay, now let's look at some more examples. All right, now we're looking at identities. We're going to prove identities. Prove identities. Now listen closely again to an important concept. In proving identities, that most of us as teachers want to make you do is to work one side down until you get it to look like the other side. Or take this side and work it till you get it to look like that side. Technically, theoretically, in mathematics, that's not necessarily true. You can work both sides until they get to be the same. But for the purpose of these problems in the course, it is to teach you those 8 fundamental identities so that you can use them in other math classes. So the purpose of these are not to work these, but to learn identities. And while you're doing that, you will learn algebra also. All right, so we need to get that side to look like this side. How do we do it? Well, your textbooks give you 6 little rules that you need to kind of read over and keep in mind. But some of my ways of saying is this. I want to try to get that to be that, so I need to get that changed over to cosines. If I only have cosine over here, then I want cosines over there somehow, some way. Another thing I say is, as I'm working this side, always have split vision so that you keep an eye on what you're trying to get to. So as you work this over here by either factoring or common denominators or whatever, then you want to keep in mind and looking at what you're trying to get to. All right, so let's do that then. The first thing to do is look for factoring, I guess. So, hey, yeah, here's a common factor. So I can factor out the sine squared of theta, and that leaves me sine squared of theta plus 2 cosine squared of theta. Now, I think it's good, wise, and that's what you should do, is learn to keep this in order. Keep the equal sign going right below it all the way. Keep your work orderly. Be very neat when you're doing identities. So I'm going to keep this equal sign down this way, and I'm not going to copy this down until I get to the last step. Until I get this over here to look like this, I won't worry about copying this down. I'm going to do that side now. Well, let's see. Have 2 of these. It looks pretty close. Sine squared plus 2 cosine squared. But if I just had one, well, what I'll do is take and split one of these off. Put a cosine squared and plus another cosine squared. All right? You do what's called the Peirce rule. You make it work. You do whatever algebra necessary to get the job done, provided it's morally and ethically correct. No cheating. Okay? So I can do that. Well, look, the reason I did that for is because what is sine squared plus cosine? That's 1. So my next step, I can make this 1 plus cosine squared. Right? Because these 2 go to 1. All Okay, that looks good. Well, now, remembering the other side had all cosines, so I want to change that. So I'm going to rewrite this as 1 minus cosine squared. And then this was 1 plus cosine squared. And look, algebra. First times the first, FOIL method is 1. Middle term drops out. Last term is cosine to the 4th theta. And I come down to the last step and put an equal, and I put what it's supposed to be equal to. Okay, so let's kind of step back and look at all those steps in one picture. And that's one way of getting it. So what I had to do is factor. How did I know? Well, I don't know how to tell you how you know. It comes from practice, and that's why we should be giving you about 30 or 40 of these. So what you do is look at examples that the teacher does, you look at examples of this tape, and you learn to look for those things, okay? And then, 30 or 40 years experience, you can handle it. Okay, so we factor out, and then we look for what we can do. Well, let's see. Hey, we could have done this another way, and I want you to see this right in here. Just keep looking at all of it as a whole. But right in here, what was my rule replacement? Okay, so right at this step, I will replace this with 1 minus cosine squared of theta, okay, plus 2. Okay, I'm just replacing this right here with 1 minus cosine squared plus this 2 cosine. Well, now what does this add up to? Well, sure enough, I get the same answer. And then replacing this with 1 minus cosine squared. And look what happens. I end up with the same step. There is not one and only one way of working trig identities. Okay. Most problems will have 2 or more ways of doing it. Some are quicker than the other and take less steps. Some take longer than the easiest way of doing it. That's not the purpose. The purpose of working identities is for you to see replacement. For practice of knowing that the sine squared is 1 minus cosine squared. Okay, knowing that the sine squared plus cosine squared is equal to 1, the way we did it a while ago. All right, let's look at another example in the notes. We have secant squared plus tangent squared is equal to secant to the 4th minus tangent to the 4th. Well, normally the way of working this is take the more complicated side and get it to go to the other side. So what we'll do then is take the right side of this and factor. This is secant squared minus tangent squared times secant squared plus tangent squared. Well, hey, that's what we want. That's what we want. So the cheating method is say, well, I'll just make that a 1 right here. Okay, so I'll just make that a 1, and I got what I want. What you need to know is that's not the cheating method. That's what that's equal to. Okay, secant squared minus tangent squared is equal to 1. Now, most teachers working identities require you, certainly I do, require that you don't skip a step in here. Now, this is okay. Going from here to here, that's great. Okay. But you better not skip a step because you don't know what you're doing, and so you're just going to skip a step. You must go step by step and show how it works through identities. Here's an identity that goes to here. All right, if you did not see that's equal to 1, it still gets there. Okay, let's go do replacement. Right here for secant, we will put 1 plus tangent squared minus this tangent squared. And look what happens. Tangent squared, that drops out. That's equal to 1. So there you would take one extra step and still get to the correct answer. And then go ahead and write down the other side. So the concept here is algebra. Do algebra, then replacement. Algebra, then replacement. Okay, let's look at the next example. All right, this one doesn't look like it makes any difference which side I work, so let's take the left side. Take the left side. What do I do? Well, let's see. I don't know what I need to do. Well, let's see. I'll just make it work then. hey, over here I want a cosine on the bottom, and I don't have it over there, so I'll just make it work. I'll multiply the top and bottom by cosine. So the concept in this problem, and you'll have 2 or 3 in your homework, where you need to multiply the top and bottom by the same thing, and it works out. Well, let's see how it works out. Cosine times cosine is cosine squared. And we'll just leave this bottom like it is. Don't multiply it out. And you know why I don't want to multiply it out? Because I kept an I over here that says I want a cosine. So I don't want to multiply this in and lose it. I want to keep it right there. Replacement. What is cosine squared? Cosine squared is 1 minus sine squared over 1 minus sine times cosine. Factoring. This looks pretty close. I'll factor the top. I'll factor in 1 minus sine times 1 plus sine. 1 minus sine times cosine. Divides out, and we have our answer. 1 plus sine over cosine. That's how you get the job done. So that's equal to 1 plus sine over cosine. All right? So here's a case that you just kind of make it work, all right? Just do what's necessary to get the other side. Well, let's see. Let's go back and look at this problem again, look at another way of doing it. Instead of multiplying the top and bottom by cosine, let's multiply the top and bottom of what we want up here. Let's multiply by 1 plus the sine. Down here, 1 plus the sine. And look what happens on this now. I'll keep the cosine up here like I have it. 1 plus sine. Down here, this is 1 minus sine squared. Well, what is 1 minus sine squared? Well, it's cosine squared. This divides out with that. Have the answer. Less steps, okay? 1 or 2 less. That's not the important concept. It's not how fast you can get it to work, not how many steps it takes. It's the process of getting the job done. All right. Let's take another example. Oops. Now, in this example, we've got to watch out. We've got different angles here. And remember, the identities are true provided the angles are the same. Well, let's see. Sine of A plus cosecant of B. I don't know. There's no identity for that. There's no multiplication, top and bottom for that, I guess. I don't know what to do. So when in doubt, change everything to sine and cosine. So here we go. All right, so I'll leave this sine of A plus 1 over sine of B. And then cosecant's 1 over sine of A plus sine of B. Okay. When in doubt, change everything to sine and cosine and do algebra. So what's the algebra? Well, the algebra is complex fractions. So I have denominator. So what I'm going to do is multiply everything, this, everything there by the common denominator of all the denominators. Well, that's my common denominator. Sine of A, sine of B is the common denominator of all those denominators. So I'm going to multiply this by the sine of A, sine of B. I'm going to multiply this by the sine of A, sine of B. I'm going to multiply this by the sine of A, sine of B. I'm going to multiply this by the sine of A, sine of B. And what I get? This times this is sine squared of A, sine of B. Multiplying this is, these drop out and just give me the sine of A. All right? On the bottom, this drops out, gives me sine of b. This multiplies together, gives me sine of a, sine of b squared. Common factor on the top is factor out of sine of a, and I have left sine of a, sine of b plus 1. Common factor on the bottom one is sine of b. Factor out, I have 1 plus sine of a, sine of b. And whoops, look there. Divides out, and we have the answer. Gets there. All right, now, let's go back and look at another way of doing this. Okay, so let's back out and look at the top up here and do it by the Peirce method again. The Peirce method is what? Just whatever it takes to get it done that's correct. Well, what I want over here is sine of A and a sine of B. So I'm going to multiply the top and bottom by sine of A, sine of B. I'm going to multiply the top and bottom by sine of A, sine of B. Alright, so we'll multiply the bottom by sine of A, sine of B. Alright, look what happens. This times this, that step that we had a while ago. And what's this times this? What is the cosecant of B times the sine of B? 1. And then this, the bottom, this times this, what is the sine of A times the cosecant of A? That's 1, so we just get the sine of B. And then this times that. So that's one less step. Still comes back to the final process, final answer, and works out. But the point of this problem was, when in doubt, if you don't see the algebra, you don't see how you do it by tricks, then change everything to sine and cosine, and then do algebra. All right, let's look at the last example on this set of notes. All right, the last one looks like a big complicated problem, but it's not that big a deal if you will think this. What is 1/2 plus 2/5? Well, an easy way of doing that is to cross multiply this and then this over this times that. Okay, so to add fractions, that's a real quick way, rather than multiplying top and bottom, which you just have two fractions. Now, if you have 3 or 4, then you must go use another process. But two fractions, very simple, this times that, plus this times that, over this times that. So let's do that process. So this times that is sine squared of, plus this times that is 1 plus cosine times 1 plus cosine. All over this times that. And I'll just leave it multiplied, don't put it together. So, what do we get on the top? Well, let's take another step here and see what all we get. We get sine squared of phi plus, first FOIL method, we get 1 plus 2 cosine of phi plus cosine squared of phi or phi, whichever way you want to pronounce it. I believe correctly it's phi, but some people don't use that. Okay. Now look what happens. Here we go. Sine squared plus this cosine squared is equal to 1. So some of you can just put down 1 plus 1 and put 2. Save a step. But basically what you should do is, let's see, this is 1 minus cosine squared plus 1 plus 2 cosine plus cosine squared all over 1 plus cosine minus cosine squared plus cosine squared. That drops out. So here on the board I'll just do it this way. That drops out, and that drops out. And here I have 1 plus 1, which is 2. All right, so that's how I got that, from that step to the next step of the notes. The cosine squares drop out, and that 1 plus this 1 is 2. Well, now I'll factor. The numerator up there, I'll factor 2 out. I have 1 plus cosine. And down here I have 1 plus cosine sine. Well, look what happens. Okay. Because I'm running out of board space, here's what I'm going to do then. So that drops out. I'm just going to erase that and move this 2 over here for the next step. So that would be the next step in your notes. And then, again, watch this for algebra. Sine and cosine and tangent, cotangent, secant, cosecant, all those can be moved up and down across the equal sign, provided you don't have any addition or subtraction in the problem. So therefore, sine just moves up and gives us the answer that we want. I can take cosecant and move it down. Right? Back and forth across the division sign, provided there's no addition. Right here, I cannot move these up and down. I have addition in the problem, so you don't move those. All right, that's one way. Another way is, if you don't see that, then go back here. What is sine equal to? Sine is equal to 1 over cosecant of theta. Now, how do you divide fractions? This divided by that, you invert and multiply. So this would be 2 times inverting and multiplying. We get the same answer. So you can still get the same answer any way that you go about the problem by using algebra. All right, now these are just a few of the examples that I can show you, but I think these are sufficient enough to get you started on the first few problems. Now, part 2, take 253, identities part 2, will give you much more complicated problems, and so you can watch that.